Alright, hello class. Today we're going to be taking a look at this percent readiness guide. We're working with converting between percents, fractions, and decimals, and we are also looking to solve some percent problems. So if we look at our first question, we're dealing with a chart, and we're working on starting with either a fraction, decimal, or a percent, and converting to the other two. And one key thing that can help us here is to remember, well, what does the percent sign itself mean? And it means out of 100, or a fraction with 100 on the bottom. The other thing we can remember with our decimals that can help us is the idea of place value, right? We've got our decimal point, we've got our tenths, meaning out of 10. We've got our hundreds, meaning out of 100. And we've got our thousandths, as in out of 1,000. And that's obviously going to help us with our decimals. Okay, so let's start with our fraction 1/2. And to write this as a percent, we need to have a 10 or 100 on the bottom, in fact, for percent. Okay, so let's get started there. Let's first off take a look at, well, if I was going to multiply this to get either a 10 or 100 or 1,000 on the bottom, I'll multiply this by 5. 5 times 2 is 10. And remember what I do at the bottom of a fraction, I have to do at the top, so 5 times 1 is just 5. Since this is 5 over 10, I can write that as the digit 5 divided by 10 in the tenths place. The 0.5 obviously is my decimal. As far as making this into a percent, well, I need 100 on the bottom, not just 10, but I do know that 100 is 10 times 10, so we'll do that further. I get 50 out of 100. And remember, we can replace that, I'll just write that over here as well. We can replace the out of 100 part with the percent sign. Oops. So all we're doing is, instead of writing a out of 100, we're writing a percent sign to represent the same thing. Okay, working back the other direction, let's first off take a look at what place our 0.65 gets to. That is the hundreds place. And what that means is we can write this as a fraction divided by 100. So we'll take our digits, which are 65, and all we have to do is divide them by 100 because we reached the 100s place in our number. Now, since this fraction is already out of 100, we know that we can replace that out of 100 with a percent sign, and there's our percent. Working the other way, this is probably the easiest one. We've got our 45%. All we do is we replace that percent sign with a division by 100. Now that we have our 45 out of 100, when we divide by 100, we're just changing place in our number. So imagine our 45, it's going to start with a decimal point at the end. And since we're dividing by 100, it moves once, twice. We get 0.45 as our decimal. Okay, and this applies to any percents, decimals, or fractions that are greater than 1 whole or 100% as well. So when we look at 1.2, again, we want to look for what place do we get to. In this case, it is the tenths place. So we take our digits 1, 2, and all we have to do is divide them by 10 to write it as a fraction. Now, if we want that as a decimal, we're going to need, as a percent, we're going to need 100 on the bottom. So we're going to multiply top and bottom by 10. End up with 120 out of 100, and therefore 120%. Again, just replacing the out of 100 with a percent sign. And let's just continue, finish up this table. 180%, replace the percent sign with a division by 100. When we have a division by 100, our decimal point moves twice. We end up with the decimal 1.8. Now 5 3/4, we want to remember that this is a mixed number. 5 is just 5, and we need to add to that 3/4, which is 0.75 if you figure it out as a decimal. And so overall here we have a value of 5.75. And in fact, we could fill that into our decimal category over here as well. Now, to help us write a percent, let's convert this to a full fraction, not a mixed one. And I'm going to look that I'm at the hundredths place. So this can be written as 575, our digits, divided by 100. And since we're out of 100, the number on the top is just our percent, so 575%. Okay, last one here, we got 0.012. Our number gets to the thousandths place. So we're going to take our digits, in this case 1, 2, and divide them by 1,000, since we're in the thousandths place. Now, to write a percent, we need it to be out of 100, not out of 1,000. So we're going to divide top and bottom by 10. That'll give us 100 on the bottom, and on the top, our decimal will just move once, so 1.2 out of 100. And we can go ahead and observe, well, since we were out of 100 there, the number on the top is your percent. Next part of our unit is arguably the easiest part as far as drawing out percents. Remember that percent means out of 100, so we're always starting with an original 10 by 10 or 100 square grid. So let's count that out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Make a grid. Now in this case, I have 105.6%. And one of these grids can only show 100%. There's 100 squares here. Each one represents 1%. So I need a full grid just to show 100%. So I need a second grid to go over 100%. 2, 3, 4, 5, 6, 7, 8, 9, 10. In this grid, I need 5 additional whole percent. So let's just kind of outline that for ourselves. There's 5 whole percent. I also need that 0.6%. If I think about 0.6, when we get to the tenths place there, that's 6 out of 10. So what I need to do is I need to zoom in on one square, and I need to represent that in that one square, I have 6 out of 10 possible things filled in. So there's your 6 out of 10 in that square. And again, this is 6 out of 10 of 1%, which is why it represents that 0.6%. All right, some basic solving questions. Again, in these ones, we want to convert the word what into a question mark, is into an equal sign. We need to convert our percents to decimals. And if we look up above, we've already done our 120%. We know it's the decimal 1.2. Of gets converted to a multiply sign, and any number without a percent sign just stays as that number. In this case, our unknown is already by itself to the left of the equal sign, and so we can just do our calculation. You could definitely use a calculator for this calculation, but let's just do it by hand. Long multiplication. All right, let's get started with our 2. 2 times 5 would be 10, so we'll write a 0 and carry a 1. 2 times 3 would be 6, plus 1 is 7. Now we're going to deal with our next placeover, so we need to put a placeholder 0. 1 times 5 is 5, and 1 times 3 is 3. Now that we've done all of our digits, we need to add up. 0 plus 0 is 0, 7 plus 5 is 12, so 2 carry a 1, and 1 plus 3 is 4. Now we have to remember to adjust for our decimal. In our calculation, we had 1 decimal point, and so in our answer, we need to have 1 decimal point as well. In this case, our answer is that 42 is 120% of 35. We just take a check. Well, 35 is 100% of 35, so 120 should be more than 35, and that's what we ended up with here. Okay. Next one, same kind of starting point, so let's go ahead and write our question mark for our what. Our of is a multiply sign, 135 is just 135. Is our equals, and 75 is just 75. Our problem here is if we look where the equal sign is, our question mark is not by itself. there is other stuff on its side of the equal sign. And so we need to solve. And when we solve, we have to undo what's being done to our question mark. So our question mark's here, and it is being multiplied by 135. To undo that, we have to do the opposite, and the opposite of multiplying is dividing. Now, what I do to one side of the equal sign, to keep it fair, I have to do to the other side as well. Okay? My 135 on top cancels with my 135 on the bottom. I'm left with just a question mark on the side of the equal sign. And on the other side, I have a calculation, 75 divided by 135. Now, this would be a good opportunity to use a calculator. You could definitely simplify this fraction a little bit if you wanted to, but you could use a calculator here and figure out that this question mark is 0.5 repeating. So we'll just round that to the nearest hundredth of 0.56 as instructed. Now we want to be careful. This is a decimal. We're asked what percent, so we're going to want to convert this to a percent. So let's observe that we're in the hundredths place there. So we'll take our digits 5, 6 and divide by 100. And since we're out of 100 here, we can observe that that is approximately 56%. Last one, let's set it up the same way. So we got our 18 is just 18. Is an equal sign. 36% we're going to need to convert. So let's go 36 out of 100. Which would move our decimal point twice to give us 0.36 as a decimal. Of is a multiply sign, and what is our question mark? Same type of deal in this situation. Let's look for our equal sign. Is our question mark by itself on one side of that equal sign? It's obviously not. We have 0.36 being multiplied by that. So we can go ahead and divide both sides by 0.36. Okay, our 0.36 on top cancels with our 0.36 on bottom. On the other side, we just have a calculation that we can do, which is 18 divided by 0.36. And we're expecting that answer to be greater than 18. So let's use a calculator to assist ourselves in doing that calculation. It would be easier to do by hand if you kept it as an actual fraction. And we end up with the answer 50. Okay, so a review of some basic setting up there, as well as our solving skills, basic solving equations. All right, on the back side, we've got a couple more questions with some context to them. The number 4 just asks us how we could mentally estimate what 15% of 25 is without using a calculator. There's lots of different ways to do this, so if you used a different method, as long as you can describe it, you should be good. What I might do is I would say 15% is equal to 10% plus 5%. And 5% is obviously half of 10%. 10% of a number is easy. We just move our decimal point once. So if we have 25 as our original number, 10% of that will be 2.5. Then 5% will be half of that, which is 1.25. We add that up. We're going to have 3 wholes and 0.75 as our decimal. So we could estimate that 15% of 25 is 3.75. And again, there would be lots of ways of going about that. Survey of 600 students found that 21.75%, let's just go ahead and convert that 3/4 to a decimal here, prefer banana splits without chocolate sauce. How many students did not want chocolate sauce? And we want to round our answer to the nearest whole. Okay, so let's go ahead and set this up. Let's use proportional reasoning since we used the percent of approach up above. I'm going to compare the number of students to the percent that represents. Compare no sauce to the total number of students. Let's just move that 21.75. All right, and when we use proportional reasoning, we are setting up two equal fractions. All right, so I do know the total number of students is 600. They surveyed 600 students, and I know that that 600 will be 100% of itself. As far as the percent that did not want sauce, it's 21.75, and we are looking for how many students that was. So we've only got one unknown here. We can go ahead and solve for it. And first thing I'm going to do is I'm going to notice that 600 divided by 100 is just 6. You don't have to do that simplification, but it makes it a little bit easier to do this by hand. Next thing I'm going to notice is my question mark is being divided by 21.75. So the opposite of that is multiplying by 21.75. Just like any equation, what I do to one side, I must do to the other. We just kind of clean this up over here. We've got just our question mark left because our 21.75 is cancelled. Equals our fraction simplified to the number 6. We need to multiply that by 21.75. And we can go ahead and work through, well, how do we get that? You could use a calculator for it, or you can go ahead and do it by hand. So 21.75 multiplied by 6. 6 times 5 is 30, so 0 carry a 3. 6 times 7 would be 42, plus 3 is 45, carry a 4. 6 times 1 is 6, plus 4 is 10, so 0 carry a 1. 6 times 2 is 12, plus 1 is 13. In our calculation, we had an original 2 decimal points, and so we need to have 2 decimal points in our answer as well. And we'd estimate that there's 130.5 students who did not want chocolate sauce. Now, since we can't have half a student, and we're asked to round to the nearest whole, 5 rounds up, and we'd estimate 131 students. 2 more questions to go. How many grams of sugar would we need to make a 1 kilogram sugar and water mix that is 0.5% sugar? Okay, let's again use proportional reasoning. I'm going to set up 2 fractions. I'm going to compare sugar to the total. And I'm going to compare mass to the percent. I know the sugar needs to be 0.5%. And I know the total will be 100% of itself. Now, since they're asking me for grams, I'm going to use grams version of this total weight. And kilo means 1,000. So 1,000 kilograms for our total mixture. And we're asked for how many grams of sugar would that be. Okay, let's go ahead and solve this out. Again, I'm going to simplify this fraction just to make my life a bit easier. 1,000 divided by 100 is 10, or difference of 1, 0 there on the top. And we just need to multiply both sides by that 0.5. Let's do that. On the left side, our 0.5s cancel out. We have question mark equals 10 times 0.5. And that is just 5. And let's just make it clear that that would be 5 grams of sugar. Last one, we've got 7.5% of the school boys play lacrosse, and that is 30 boys. How many boys are in the school? Could also solve this by using proportional reasoning, but let's just go back to the percent of approach. First thing is I want to convert my percent into a decimal or a fraction. So 7.5% would be 7.5 out of 100, which is 0.075. There we go. We have of the school boys, which is what we're asked about, play lacrosse, and that amount is 30 boys. So 7.5% of the total is 30 boys. And we can go ahead and solve this out. We're going to divide both sides by 0.075. Our 0.075s will cancel on the left side of the equal sign, or question mark, equal whatever that calculation is on the right side. I can use my calculator to help me. 30 divided by 0.075 gives me 400 boys attending the school. And that's how you work through some of those basic percent problems. Hope that helped you out.